Hello, my name is Kenneth Chow, or you may call me Man Chow. And last time in my video 13, I did the proof of that the gravity is identical with the strong force and also with the electromagnetism. Actually, my proof is that the electromagnetism and gravity are identical. And I also demonstrated that how the gravity is only 10 to the power minus 39 part of the magnitude of strong force. I did both of this, and this time this is my quantum video gravity series video 14. What I'm going to prove is that the difference, what we call the difference of 1/137.036 or 7.297 times 10 to the power minus 3 between, which is actually the repeated value of the fine structure constant between the strong nuclear force and the electromagnetic force. How that came about. I explained in video 1 of my video series, quantum video series, quantum gravity series. It's actually the conversion factor from E2. The E is represent the elementary charge squared, the squared E squared, to mass times distance. The distance or the length or the radius or the wavelength, and vice versa. That is also from mass times distance back to E squared. Once this is understood, then there is no difference. That is the strong nuclear force, electromagnetic force, and gravity are all identical. If they look different, it is only due to the mass term in the numerator and the length distance term in the denominator, as I explained in video 13. When both mass and distance length terms are set to be the same, then the strong electromagnetic and the gravity forces should look identical. As I demonstrated in video 6, when the wavelength radius is set to the poton radius, 0.21 times 10 to the power minus 15 meter, the EM, the electromagnetic potential under the Coulomb law, is exactly the same as the strong nuclear potential in magnitudes, both equal to 1.1 times 10 to the power minus 12 joule. In my last video, video 13, I demonstrated how both the Newton's law equation and the Coulomb's law equation can be reduced to the form F is equal to F represents force in newtons, is equal to mass times c squared divided by the r, the radius or wavelength. This is you have to refer back to my video 13, equations 5 and 6. And I show it once again here. And using the fine structure constant alpha equal to 1/137.036 or 7.297 times 10 to the power minus 3. Please note that I'm using the SI units as a statutory international kilogram meter second unit instead of the CGS unit in America. And I also make use of the fact of the G, the Newton gravity constant is equal to Planck length divided by Planck mass times c square. And the third equation I make use of is 1 over 4 pi times 10 to the power minus 7 times epsilon naught is equal to c square here. When both the Newton law equation and the Coulomb's law equation can be converted, when I apply all of these three facts, mathematical facts, physical facts, both the Newton law equation and the Coulomb law equation can be converted to another form, that is in this form. F is equal to 10 to the power minus 7 times E square times C square divided by R square. You remember that E square is elementary charge square, and R square is equal to the radius or wavelength of charge squared. And then both equation 5 and 6 are entirely equivalent to equation 11. This is equation 11. And then if you use all the three equations, that's G is equal to Planck length divided by Planck mass times c square, and then also the 1 over 4 pi epsilon naught times 10 to the power minus 7 is equal to c square. Then you get both equation 5 and 6. This one is equal to this one. Thus, for electron, you have F is equal to F is the force, the electromagnetic force, 10 to the power minus 7 times c square divided by 3.86 times 10 to the power minus 13 all square. The 3.86 times 10 to the power minus 13 is what you call the Compton wavelength, for electron. And it actually is usually given in 2.423 times 10 to the power minus 13, but that is for the whole circumference of the wavelength And if for you now I'm extracting out the radius. The radius, of course, is equal to 2 pi circumference divided by 2 pi. So 2.423 times 10 to the power minus 12 meter, 30 meter is equal to 3.86 times 10 to the power minus 12 meter. And this whole expression here, the force, it becomes 1.55 times 10 to the power minus 3 Newton. Under equation 6, you have the force equal to 9.109 times 10 to the power minus 13 times c square divided by 3.86 times 10 to the power minus 13. This is using equation 5 or 6. And what you got is 21.2386 times 10 to the power minus 2 Newton. So you think, oh, that must be a difference. Looks like it has a difference. But actually, the difference is a factor. Just a factor of 1.136.036, or alpha, the fine structural constant, which is that's the conversion factor that I mentioned in video 13 and in this video earlier. And that is we have 21.239 times 10 to the power minus 2 multiplied by 7.297 times 10 to the power minus 3 is 1.55 times 10 to the minus 13 Newton. That actually is that's a convection factor. Okay. This is just a proof. That's a demonstrate how the difference of 1 over 137.036 between the nuclear strong force and the gravity and the electromagnetism, magnetic force came about. This is just equal to the alpha, the fine structure constant, which is a conversion factor. Now, secondly, I'm coming to the weak interactions. We'll cover the gravity, we'll cover electromagnetism, electromagnetic force, gravity force, and electromagnetic force. Their comparison with strong force, they're identical. That they are identical with strong force, with a strong nuclear force. So the only remaining thing is to the weak interactions. The weak interaction is actually not a force like the electromagnetic force or the gravity force. It's actually an interaction, just simply an interaction, which changes the identity of certain particles. We have several tables here. The weak interactions. Some typical examples. The one is the electron. It is the typical decay and the mean life is stable. So the mean life, of course, is definitely long and it's stable. And then secondly, we have the electron neutrino, which oscillates to the other neutrinos. We have secondly, we have the muon. Muon is decay. The typical decay is mu to a electron plus a mu neutrino plus a anti-electron neutrino. And the mean life is 2.2 times 10 to the power minus 6 seconds. You look at how it's transient. It's, to say it is a transient temporarily short is just an understatement. It is actually like a lightning flash. It disappears like a lightning flash. And the muon neutrino, it oscillates to the typical decay type is it oscillates to other neutrinos. And then we have the third, the tau neutrino, the tau particle. Its tau is equal to minus typically it decays to an electron plus a tau neutrino plus a anti-electron neutrino, and its decay time is 2.9 times 10 to the power minus 13. It's even much more transient than the previous one. Second, and it's likewise the tau neutrino oscillates. The decay type is it oscillates to other neutrinos. And next we have the list of this. We have the I better read it out first. The proton, the baryons, and the typical decay is not known yet. Any decay. It is mean life is more than estimated to be more than 10 to the power 29 years. And then we have next we have a neutron, and then the neutron typically decays to a proton plus an electron plus a anti-electron neutrino, and the mean life is the free electron mean life. It means it once the neutrons is dissociated from a atom, it will be a free neutron, and it will be the mean life is 886 seconds, a little bit less than 50 minutes, 14.76 minutes. Next we have a lambda particle. Lambda is typically decays to a proton plus a negative pi negative, a pion, what we call it pi, and its decay time is the mean life before it decays is 2.6 times 10 to the power minus 10 seconds. It's extremely transient. It's actually 10 billion of a second. The sigma, next to a sigma it is divided into sigma is divided into the positive and the neutral. The positive decays to a neutron plus a pion, positive pion. Its decay time is 0.86 times 10 to the power minus 10. And the next to a sigma neutral it decays typically decays to a lambda plus a photon, and its decay mean life is 7 times 10 to the power minus 20 seconds. And then next we have omega. Omega typically decays to a lambda plus a kaon, K negative. Its mean life is 0.86 times 10 to the power minus 10 seconds. And next we have a pion, pi negative decays to a muon. Muon is negative. It's like an electron. It's negative charge. And plus muon neutrino. And pi positive decays to a muon positive as mu neutrino, and its mean life is 2.6 times 10 to the power minus 8 seconds. And a pi neutral decays to 2 photons. Next I will show you that it's gamma photons. It's not just any photons, gamma photons. Its mean life is 8 times 10 to the power minus 17 seconds. And eta particle next up. Eta particle decays to a pi positive and a pi neutral plus a pi negative, and its mean life is 5.6 times 10 to the power minus 19 seconds. Next we have a kaon. Kaon negative decays to a muon, which is negative, which has negative charge, plus a anti-muon neutrino, and its mean life is 1.24 times 10 to the power minus 8 seconds. Next, we have the neutral kaon, which decays to a pi positive plus a pi negative, with mean life 0.86 times 10 to the power 10 seconds. All these I got the source of all these figures. I got it from the table 8.1 and table 8.4 of 101 quantum questions by Kenneth Court. And so here. Okay. Apart from the 1 to 8, which appear final. 1 to 8. What do you mean by 1 to 8 is here? Mostly of this 1 to 8 is just for the leptons, the electron neutrino, the muon neutrino, and the tauon and the tau neutrino, and the proton and the neutron. It appears to be final. The decay types appear to be final. And remembering the matter annihilates with antimatter, so they become annihilated to naught, just nothing. Just remember two facts. Then the final remaining particles of interaction decays, which I've already shown you. All these typical weak interaction decays are, we have the final particles here. I better read it out. And then we have lambda. The lambda particle, it finally, after it decays, the finally remaining particles, a proton plus a neutron plus an anti-electron neutrino, and then sigma positive, then the finally remaining particles, just the proton. The sigma neutral and the final remaining particle is just the proton plus an electron plus an anti-electron neutrino plus a gamma ray photon, one gamma ray photon. And we have the omega. Omega is the final remaining particle after decay from omega. Will become just a proton plus 2 electrons plus 2 anti-electron neutrinos. And the pion, the positive pion, the final remaining particle after decay of a positive pion will just be a positive electron in this case, a positron, plus 2 mu neutrino plus an anti-electron neutrino, and the pi negative will just decay finally to an electron plus an anti-electron neutrino. And for the pion neutral, it's just the final product is just 2 gamma ray photons. And for the ether particle, the final product is 2 gamma ray photons. For the kaon, negative kaon, the final remaining product is just an electron plus anti-electron neutrino. And for the positive kaon, the final product is just a positron. That's a positive electron plus a electron neutrino. And for the kaon neutral, it's just 2 gamma ray. The final product is just 2 gamma ray photons. That's the finally remaining particles. Just you can see from this list here. Are all just proton, positron or electron, and a mu neutrino or anti-mu neutrino or electron neutrino, or anti-electron neutrino, and a gamma ray photon. So it's from this it's intuitive and logical inference will come to your mind that the baryons 9, 10, 11, 12, 13, 14 are and also including neutron and muon as well, are just transient excited states of a proton and electron, and that the decays are just a phenomena of the damped oscillations of the individual excited states. A synoptic diagram of the damped oscillation is drawn to show this concept. It shows that the omega, this is for an omega, for the omega. For this diagram, it's for damped oscillation of omega to the proton plus 2 electrons plus 2 anti-electron neutrinos. The omega is created by injecting external energy into the system, for example in a cyclotron. The excited de Broglie matter waves is then damped into the final products. This phenomenological method of interpreting the decays related to weak interaction is consistent with the new hydrogen atom model, which is equivalent to the Planck black hole plus de Broglie matter wave model. Both of these concepts are postulated by me. You can see this from my videos 2, 3, and 4 of my quantum gravity video series. So I think I've stopped here. So if you like my videos, you can subscribe and like.